Hey there guys, welcome to my walkthrough of the November 2018 AQA Higher GCSE Maths Paper 2. It's a calculator paper, so we'll probably only need to use our calculator twice. There will be lots of useful stuff in the description down below. Make sure you take a peek, including my playlist containing every higher AQA past paper walkthrough. Pretty useful. Okay, let's go. Okay then, let's see what hell awaits us. So, question 1. What does A, N, B, no it's not really an N, we read this as A intersection B. What does A intersection B represent in P brackets A intersection B? So that means, that whole thing means the probability of A intersection B. Now, in English, A intersection B means A and B. So, this guy here. Now I'm also going to go through how we would write these other statements in set notation. That's all this stuff is. So A or B or both we would write as A union B. That means A or B or both. Not A and not B. Well, not A we write as A dash. So if we want and not B, we write it like that. And A but not B means A and not B. So that's A intersection B dash. Bonus information, never hurt anyone. Question 2. B is 4, 9 and Q is -2, 1. Circle the midpoint of PQ. Okay, so midpoints are the mean of the x coordinates and the y coordinates. So to find the x coordinate, we are going to do 4 add -2, so that's 4 minus 2 over 2, so that's the mean of the x coordinates. Same for the y's, so 9 add 1 over 2, so that it's going to give us 2 over 2 is 1, 10 over 2 is 5. So it's 1, 5. Okay, 3. Which of these is a geometric progression? So progression means sequence, sequence means progression. They are the same thing. Now I'll put my sequences playlist down below. So let's go through what each of these is. So 1, 3, 5, 7, 9. We can see that we are adding 2 to get from term to term. Now a sequence or progression where you add the same amount is called arithmetic. So, not that guy. 1, 4, 9, 16, 25. Hopefully you recognise these as R squared numbers. Now, to get from term to term, the differences change. If we look at the second difference, we're adding 2. So this is a quadratic sequence. Now the same is true for the top right, 1, 3, 6, 10, 15. We are adding 2, then adding 3, then adding 4, etc. So that one is also quadratic. This guy is our winner. Geometric sequences are when you multiply by the same amount to get from term to term. So here we're timesing by 3 each time. So this is our geometric progression. Cool. Okay, number 4. The bearing of A from B is 310. What is the bearing of B from A? Okay, two things with bearings. North is 0 degrees and we measure them clockwise. So, let's make a sketch. Let's put A there, and then because the bearing of A from B is 310, B is going to have to be down here somewhere. Now if we put a cheeky little north line on each point, join them together with a straight line. Now we know that this angle here is the bearing of A from B. So we know this is 310 degrees. Angles around a point add up to 360, so this angle has to be 50 degrees. Now we want the bearing of B from A, so that is this angle here. Remember the north lines are parallel, so these two angles are co-interior, which means they add together to give us 180. So this angle has to be, or bearing has to be 130. Cool. Okay, number 5. A circle has circumference C and diameter D. C is KD. What value does the constant K represent? Well, circumference is pi times diameter. So here, K represents pi. Cool. Okay, question 6. We have frequency tables, so I'll put my stuff down below. So the table shows information about 20 trains leaving a station. So we got the number of minutes late, T. We got the number of trains. We got 2 empty columns. And part A answers to work out an estimate of the mean number of minutes late. Okay, so they've told us what to do in the first column, which is to find the midpoint of each interval. So 0 to 5 is 2.5, 5 to 10, 7.5, 10 to 15 is 12.5, and greater than 15 has no midpoint. But that doesn't matter because there's 0 trains in here anyway. Okay, now we have this other empty column. So the reason that we take the midpoint of each interval is that gives us an estimate of the mean time in that interval. So what we now need to get is an estimate of the total time of late trains in each interval. So how we do that is we do the midpoint times the frequency. So 12 times 2.5 is 30. 7.5 times 7 is, use your calculators, 49 and 3.5, 52.5. 12.5 times 1, I can do that, that's 12.5, nothing in the last row. So, what we now need is the total. So, 12.5 add 52.5 is 65, add 30 gives us 95. Now the mean is total, so 95 divided by total frequency, so 20, and that gives us 4.75 minutes. Cool. Okay, then for part B, the station manager looks at the information in more detail. So, he has broken the intervals into smaller whips. So we had intervals of 5, he has intervals of 2. He works out an estimate of the mean using his information. How does his estimate compare to the answer to part A? Is it higher, the same, lower, or impossible to tell? Well, let's work out what he would get for his total. So let's do his midpoints times its frequencies. So the midpoint of 0 to 2 is 1. 1 times 12 is 12. We got a 0 in the next one, so we just put 0. The midpoint of 4 to 6 is 5. 5 times 7 is 35. 0 there, 0 there. And then the midpoint of 10 to 12 is 11. So 1 times 11 is 11. So his total is, these numbers added together, 12 and 35 is 47, add 11 is 58. So, he has a lower total than we had, so his mean would be lower. We don't need to work it out, but we could. 58 over 20, but the important thing is it's going to be lower. Okay, question 7, 4 marks. We want to work out the values of A and B in the identity. 5 lots of 7x add 8, add 3 lots of 2x add B is identical to AX add 13. So a 3-line equals sign means the left hand side is identical to the right hand side. So we are not trying to solve for x because it's not an equation. First job is to change colour because I'm bored of orange. second job is to expand the left hand side. So 5 times 7x, 35x, add 40, add 6x, add 3b. Let's simplify that. So we got 35 add 6x, 41x, add 40, add 3b. So we know that that is identical to ax add 13. So what this means is that we must have the exact same amount of x on the left as we have on the right, and we must have the exact same constant term, so that means the bit without any x on both sides. So let's compare the x's first. So we got 41x over here, and we got ax over here. So that means then that a has to be 41. Now, in terms of the constants, on the left we got 40 add 3b, on the right we have 13. So 40 add 3b has to be 13. Now we want to solve that for b, so take away the 40. 3b is minus 27, divided by 3, b is minus 9. Boom. Okay, question 8. Two identical chord circles are cut from a rectangle as shown. We want to work out the shaded area. 4 marks again. Okay, so at first it might seem like we don't know very much. All that we know is the height of the rectangle, but we know that these chord circles are identical, so that means this length is equal to that length. Now, because they are chord circles, we also know that these lengths are a radius of the circle. So we also know this is the same, so is this. So the radius of the circle is half the length of the rectangle, which is 6. So the area of the rectangle is equal to 6 times 12, which is 72 centimeters squared. Now then, if we've got 2 chord circles, we've got half a circle. So, for a whole circle with radius 6, the area is pi times 6 squared, 36 pi centimeters squared. So the area of the 2 chord circles is half of 36 pi. So it's 18 pi centimeters squared. So the shaded area is the rectangle, so 72 minus 18 pi centimeters squared. Now they haven't asked for it in decimal form, so I'm just going to leave it in terms of pi. You can turn it into a decimal if you wish, but it's more work, why bother? Okay, question 9. So I know everyone's loved this question. When I say love, hate, same thing. So the diagrams show the position of a tap when off and fully on. The tap is fully on when the angle of turn is 180 degrees. Okay. When fully on, water flows out of the tap at 14 litres per minute. The rate at which water flows out of the tap is in direct proportion to the angle of turn. The tap is turned to 135 degrees. The water flows into a tank with a capacity of 79.8 litres. Will it take less than 7.5 minutes to fill the tank? You must show your working. Okay, 4 marks again. So it's really weird with this one. It's caused a lot of confusion. Let's try and understand what's going on with the tap. So most of my minions, as soon as I've said how fast does water flow out if the tap was at 90 degrees, they've been able to tell me straight away it would come out at 7 litres per minute, because 90 degrees is half of 180. So we just need to think about what is 135 as a fraction of 180. So 135 over 180, whack it in your calculator, it's 3/4. So the rate of flow, just like if the tap was 90 degrees open, it would be half of 14. It's 3/4 open, so it's going to be 3/4 of 14. So on your calculator, do 3/4 times 14, and that will give us 10.5 litres per minute. Now, there's 2 ways to do this now. We know that every minute 10.5 litres is coming out. So we want to know, will it take less than 7.5 minutes to fill the tank? So we could work out how much it would flow out over 7.5 minutes. To do that, you would do 7.5 times 10.5. The other way to do it is to do the capacity of the tank. So 79.8. Now this is the way that I'm going to do it. 79.8 divided by 10.5. Now that is asking how many minutes will it take to completely fill the tank. So 79.8 divided by 10.5 gives us 7.6. So it takes 7.6 minutes to fill the tank. So no is the answer. It does not take less than 7.5 minutes. Okay, question 10, another one that I know causes problems, 5 marks. So they're also throwing a lot of big questions at us altogether. So this triangle is equilateral. Straight away, we need to be thinking about what that means. That means all 3 side lengths are the same and all of the angles are the same, but we don't really care about those. We want to work out, is the perimeter of the triangle greater than 1 meter? We must show our working. Okay, so each of the 3 sides are given to us algebraically. So we got 6x add 10, we got 4x add 5, and we've got 10 lots of x minus 4. Now, what this question really is about is forming and solving an equation. We need to find the value of x to be able to find the perimeter of the triangle. Now, it's equilateral, so we know that all 3 sides are the same. In maths, to show that things are the same, we stick an equals between them. So we can pick any 2 of these sides to form an equation. So I'm going to use the top 2 purely because down there's brackets, which is an atom more work, and I don't like doing more work than I have to. So we can say that 6x minus 10 is equal to 4x add 5. Again, because the sides are the same length. So 6x minus 10 is equal to 4x add 5. Now, if we solve this for x, we can then work out the side length, we can then work out perimeter. So, let's subtract 4x from both sides, so we get 2x minus 10 is equal to 5. Add 10, 2x is equal to 15, divided by 2, x is 7.5 centimetres. Cool. So, now that we know what x is, we can work out a side length. Now we can use any of the 3 sides. So I'm going to use this one because it's clearer over here. So 4 times 7.5 centimetres and 5 centimetres. It's going to give us 35 centimetres. So side length is 35 centimetres. So the perimeter is 3 times 35 centimetres, which is 105, which is 1.05 metres. So, is the perimeter greater than 1 metre? Yes. Okay, question 11. An approximation to the value of pi is given by this lovely thing here. We want to, for 2 marks, use our calculator to show that this approximation is within 0.1 of 3.14. So, essentially, stick this lovely looking thing into your calculator, which I could do and take a photo of, but it would look exactly as it does here, so it'd be pointless. Just be careful with the brackets, use the fraction button, then you should get 3.041 blah blah blah. So the approximation is equal to 3.041 blah blah blah. Now if we want to show that is within 0.1 of 3.14, all that we do is 3.14 minus 3.041, and that gives us 0.099. Okay, question 12 for 2 marks. Wants us to work out 9.12 times 10 to the 10 over 3.2 times 10 to the 4, giving our answer in standard form. So, this time, here is what I did on my calculator. Use the fraction button, use brackets just to be safe. Hopefully you can get the 2850000. So that is, remember to write a number in standard form, we're going to have 2.85 times 10, and then for the power we need to know how many places the decimal moves. So it's going to go 1, 2, 3, 4, 5, 6. So it's times 10 to the power 6. Boom. Okay, question 13. Ashraf is going to put boxes into a crate. The crate is a cuboid measuring 2.5 meters by 2 meters by 1.2 meters. Each box is a cube of length 50 centimeters. He does these calculations. So he works out the volume of the crate, works out the volume of a cube, divides the volume of the crate by the volume of a box, and he gets 48. He claims that he can put 48 boxes into the crate. We want to evaluate Ashraf's method and claim. So, Ashraf's method is shit. So, his method is wrong. So, he's found the volume of the crate. That's not wrong at all. But the problem is, you can't just divide the volume of something by the volume of something else and fit that amount of the second thing into the first thing. For example, looking on my table, if I tried to put my Rubik's Cube into my Lucozade bottle, so I think my Rubik's Cube would have a smaller volume, it's not going to fit because it's the wrong shape. So, what we should do, let's think about this crate. So let's say that this is the plan view. So we're looking at it from above. Now it doesn't matter which dimensions we use. Let's say we're going to use Okay, so let's say that we have a length of 2.5 and a width of 2 meters. So, like that. Now, each box is 50 centimeters is 0.5 meters. So, going along the length, we can get 5 boxes in. 5 lots of 0.5 is 2.5. Now going along the width, we can get 4 in. So, if we're looking down from above, we can get 20 boxes per layer. Now, imagine that we're looking at the box from the side. So we got our width of 2 meters. So this is the side elevation. Now, if we've got one layer in there, we know that that's going to have a height of 0.5. Now the other dimension of the crate was 1.2. So we know this height overall is 1.2 meters. So there's only room for one more layer. So that's going to take us up to a height of 1 meter. So we can only get 2 layers of, where am I going to write it? So we can only put in 2 layers of 20 boxes, which means 40 boxes. Cool. Okay, question 14. So, the cross-section of a prism has n sides. Circle the expression for the number of edges of the prism. Okay, so let's try this with a few prisms. So let's go with a triangular prism. So there's 3 sides. Now an edge of a prism is essentially any line that we have to draw when we draw it. So we can see a triangular prism is going to have 9 edges. Let's do it with a cuboid. So the cuboid is going to have 4 on the 2 squares, front and back, and then 4 around the edge. So here, when n is 3, edges is 9. Here, when n is 4, edges is 12. So it's 3 times the number of sides of the cross-section, 3n. Okay, question 15, another full marker. So the volume of a medal is 45 centimeters cubed. The medal is made from copper and tin. Volume of copper to volume of tin is 22 to 3. So C to T, 22 to 3. The density of copper is 8.96 grams per centimeter cubed. the density of tin is 7.31 grams per centimetre cubed. Work out the mass of the metal. Okay, so we're going to need the formula for density. Now there's good news, if you can't remember it, it's given to us here. Grams is a measure of mass, centimetres cubed is a measure of volume. So, density, I swear down, I've had so many interruptions on this paper. Density is mass over volume. So what we're actually going to want to be working out is mass. So mass is density times volume. So what we need to do for copper and tin is work out the volume of each in the middle. So that's where the ratio comes in. So we want to split 45 into this ratio. So add the parts together, 22 add 3 is 25. 45 divided by 25 is 1.8. So we then multiply each part of the ratio by 1.8. So that's going to give us 39.6 to 5.4. So the mass of copper is 39.6 times the density, which is 8.96, and the mass of tin is 5.4 times 7.31. So the total mass is those two added together. So using your calculator, we should get 394.29 grams. Cool. Okay, question 16. The cumulative frequency graph shows information about the masses of 50 apples. Part A wants us to use the graph to estimate the median mass. So the median is the middle. We go across from the 50% value on the y-axis. So half of 50 is 25, which is there. So we go across till we hit the graph, which is there, go down to the x-axis, which is there at 106 grams. Okay, part B, estimate the proportion of the apples that have a mass greater than 115 grams. Okay, so we go in reverse this time. Find 115. So what we want are all the apples to the right of that. So we go up till we hit the graph, which is there. So we want all the apples on this part of the graph go across till we hit the y-axis, which is there at 42. So we want all of these apples, so it's 50, take 42, which gives us 8. So that's the number of apples we want in the proportion, so it's 8 out of 50. Cool. Okay, 17. A is a prime number, B is an even number, N is A squared, add A, B. Circle the correct statement about N. So, could it be even or odd? Yes. 2 is a prime number. So let's say that A was 2, B can be 4, and we can see that we would get 2 squared and 8, which would be 12, so that's even. If A was odd, though, then say it's 3, 3 squared is 9, B can be 2, so then we'd have 9 add 6, which is odd, so it can be even or odd. Okay, question 18, last bit of probability. So there are, or a bag contains 20 discs. 10 are red, 7 are blue, 3 are green. Marie takes a disc at random before putting it back in the bag. Nick takes a disc at random before putting it back in the bag. Ollie takes a disc at random. Work out the probability that they all take a red disc. Okay, so because the discs are being replaced, these events are independent. So the probability of each of them picking a red is the same because the discs are being put back in. So, probability of red is, well, there are 10 red and there are 20 in the bag altogether, so it's 10 out of 20, which is 1/2. Now the probability that they all take a red then is just, so the probability of, let's say, red, red, red is just 1/2 times 1/2 times 1/2, which gives us 1/8. Okay, then for part B, all 20 discs are in the bag. Reggie takes 3 discs at random, one after the other. After he takes a disc, he does not put it back in the bag. His first disc is blue. We want to work out the probability that all 3 discs are different colours. Right, first up then, these are now dependent events because we are not putting discs back. So let's think about the situation after his first pick. So there are now 19 discs. 10 are red. There were 7 blue, so there's now 6 blue and 3 green. Now then, we want all 3 discs to be different colours, so we want the second to be red and third green, or second to be green and third to be red. Now we could use a tree diagram. In fact, let's do that. So it's going to be a very bare bones tree diagram though. So now the reason that we're not including blue is because we want each disc to be a different colour. So the probability of getting a red is 10 out of 19. Probability of getting green is 3 out of 19. Now on his third selection, if he got a red on his second, we only now care about him getting a green. So remember, there's now one less disc, so it's now out of 18, and there are 3 green. Now that is 1/6. Or if he picks green on his second, we then only care about him picking a red. So that probability is now 10 out of 18. Okay, so these are the two outcomes then that we care about. So we now multiply along the branches. So the top one is 10/19 times a 6. Now that is 10 over 6 times 19 is 114. Now that is 5 over 57. And then this chap down here, 3/19 times 10/18. Well, 10/18 is 5/9. So that's going to give us 15 over 9 times 19 is 171. Now that is going to simplify to 5 over 57. So now we add the probabilities of the outcomes that we are interested in together. So 5 57ths add 5 57ths is 10 57ths. Cool. Okay, question 19. Lunch. Great idea. Choose one starter and one main course. There are 4 starters and 10 main courses to choose from. 2 of the starters and 3 of the mains are suitable for vegans. What percentage of the possible lunches have both courses suitable for vegans? Okay, so this is what they call product rule for counting. So to work out total combinations, total combos is just the number of starters times the number of mains. So 4 times 10 is 40. suitable for vegans. Or the combos that are suitable for vegans. Well, there's 2 of the starters and 3 of the mains, so that's 2 times 3. Which, on a really good day, is 6. So, the fraction is 6 out of 40. They want it as a percentage, so without a calculator we could go, well, that's 3 over 20, which is 15 over 100, which is 15%. And you could also have put the fraction into your calculator, multiplied it by 100, there's your percentage. Good times. Okay, 20, some nice algebraic proof, so I'll put my playlist on this down below. N is a positive integer, so a positive whole number. Prove algebraically that 2n squared, lots of 3 over n, add 6n times n squared minus 1 is a cube number. 3 marks. So, with algebraic proof, never just substitute values in, because you're not proving anything other than the fact it works or doesn't work for that particular case. So, it's a very common first move that we need to expand brackets. So that is exactly what we need to do here. So, 2n squared times 3 over n is 6 n squared over n, and then 2n squared add n is 2n cubed. Then we got add 6n times n squared is 6n cubed, and then 6n times minus 1 gives us minus 6n. Okay, 6n squared over n is 6n, add, so we got 2n cubed, add 6n cubed, so we got add 8n cubed, and then we got minus 6n. Now the 6n's cancel, so this is just 8n cubed. Now, luckily, 8 is a cube number, n cubed is a cube number, so we can write this as 2n all cubed, which is a cube number. Now, at the end of a proof, whack in a little style, put a cheeky little QED, quite enough, done. Okay, 21 we have proportion, so my playlist is down below. So, y is inversely proportional to a root x. Straight away, I'm going to write down y is proportional to 1 over root x, and that means y is equal to k over root x. Y is 4 when x is 9. Work out an equation linking y and x. So we need to find the value of k in y equals k over root x. So we substitute in these values. So y is 4, x is 9, gives us 4 is equal to k over root 9, which is 3. That means then that k over 3 is equal to 4, therefore k is equal to 12, and y is equal to 12 over root x. Cool. Okay, part B, 2 marks. Work out the value of y when x is 25. So we're going to get y is 12 over root 25, which is 12 over 5, which is 2.4. Boom. Okay, 22. We want to simplify fully x to the 5 minus 4x cubed over 3x minus 6. Algebraic fractions, always a good time. My playlist is down below. So, the key to simplifying these is always to factorise. So, let's see what common factors we can see. So, up on top, the highest common power of x is x cubed. So we can say the top is x cubed times x squared minus 4. And on the bottom, there's a common factor of 3. So on the bottom we get 3 lots x minus 2. Now from that, it may look like we can't go any further, but this is a special type of quadratic. It's a difference of 2 squares. Lots more examples in my quadratics playlist down below. So that can factorise further to x cubed times x plus 2 times x minus 2 all over 3 lots x minus 2. And there's a common factor then between the top and the bottom of x minus 2. So we get left with x cubed times x add 2 all over 3. Now that really should be fine, but we could expand the top and say it's x to the 4 add 2x cubed all over 3. Nothing else we can do. 23. PQR is a straight line. P to Q to Q to R is 3, 2, 1. P to Q or vector P to Q is little a. Circle the vector R to Q. Sorry. No? Yeah, R to Q. Right. So, we know that P to Q is just little a. Now we know that P to Q is 3 times longer than Q to R. So, that means to get from Q to R, we would go 1/3 of A, but we want the vector R to Q. So R to Q is going negatively along 1/3 A. So it's minus 1/3 A. Cool. 24 transformations of graphs video down below. Here is a sketch of y equals f of x. The curve passes through these points. Here's our sketch. We want to, on the grid, sketch the curve y equals f of x add 2. So, f of x add 2 is a translation of f of x 2 places left. X transformations always do the opposite of what you would probably expect. So f of x add 2 moves us 2 places left. So all that we need to do is make sure the scale is nice, so it is every 1 square just represents 1, and every point just moves 2 places left. So just make sure you put all of the important ones in. So we got that one, and then we got, guess we can put the x-intercept in, so that's just going to be to the right of -1. It's going to be there. We got this nice point here, 1 minus 1, so that's now going to be a -1 minus 1. Then got the intercept 0 minus 2, it's now going to be a -2 minus 2. Got this point here, it's quite a nice one to get in. And then we got this guy down here, just gonna be there. So, our points should look something like that. Now I'm not gonna try and join them up because it won't go very well. In the real thing, you want to join them up, and that's it. Cool. K25, ABC and ACD are triangles. God, they tell us, because at this point, when your head's this tired, it could be anything. So, we want to, tale as old as time, work out the size of angle x. So that seems quite innocent. It's 5 marks. So, right, okay. So, let's see. Our goal is to work out this guy. We know this length. We know the angle opposite that length. This triangle is a non-right-angled triangle. So we have a matching pair of angle and side length. So we must be thinking sine rule. Now, if only we knew the height of the right-angled triangle, that would be awesome. Luckily, we're clever, we can work that out. So, this triangle on the right is a right-angled triangle. Inside of right-angled triangles, we can play SOHCAHTOA. So, we know this angle, and we know this length. So, with regards to this angle, this line here is the opposite, and this length is the adjacent. So, is it SO? No. CA? No. TOA? Yes. So that tells us tan 49 is equal to the opposite over the adjacent 16. So, multiplied through by 16, we get the opposite is equal to 16 tan 49, which is 18.4 centimetres. Socktower stuff, by the way, is down below, as is sine rule, cosine rule, area of a triangle with trigonometry. It's a good time, check it out. Okay, so we now know that this length is 18.4 centimetres. So now we're in a non-right angle triangle where we have a matching pair of opposite side and angle. One other known thing, we can work out angle x. So the sine rule, and if you're rusty on your formulas still, check out my formula video down below, where you can also get a printable PDF copy. Awesome. Sine rule tells us sine of x over 18.4 is equal to sine 35 over 20. Now multiply through by 18.4, sine of x is equal to 18.4 sine 35 all over 20. Make sure for that, yeah, sine of x is 0.528. So to get x is the inverse sine 0.528, which gives us to 1 decimal 31.9 degrees. Boom. Okay, 26 functions. Whole playlist on these guys down below. F of x is x over x add 2. G of x is x squared minus 2. Work out f g of x. Give your answer in the form a add bx to the power of n, where a, b and n are integers, whole numbers. Okay, so f g of x means f of g of x. So we are putting the g function into the f function. If you like, the f function is eating the g function. So the x in f of x, or anywhere that there is an x, it becomes x squared minus 2. So we get, well, the x on top becomes x squared minus 2. On the bottom, we get x squared minus 2 add 2, because we got the x add 2. So x squared minus 2 add 2. So again, what's happened there is the x's in f of x have become x squared minus 2. Okay, so x squared minus 2, now on the bottom, minus 2 add 2 cancels out. So on the bottom, we've just got x squared. Now, we can split this fraction into x squared over x squared minus 2 over x squared. X squared over x squared is 1. There we go, minus 2. Now, remember they want this in the form a add b x to the n. Now, never worry, just because they've got plus bx here, don't worry that we've got negative. All that means is that b is a negative number. here it's minus 2. Now, so we want b x to the n. So we don't want the x on the bottom of a fraction. So 1 over x squared is x to the minus 2. So we got 1 minus 2 x to the minus 2. Cool. Okay, 27, probably a pretty scary one. These November papers, to me, seem very, very A-level-y. These are probably actually the toughest set of GCSE that I've seen so far. So, point 3, 1 over 64 lies on the curve y equals k to the power of x, where k is a constant. So that just means a number. We want to show that 1/2 also lies on the curve. So, what we need to do is find the value of k. So remember, coordinates tell us that at a particular point, when x has a certain value, y has a certain value. So, we know when x is 3, y is 1 over 64. So if we substitute those values in, we get 1 over 64 is equal to k to the power of 3. Now if we cube root, that gives us 1 over 4 is equal to k. So k is equal to a quarter. So now we know that y is equal to a quarter to the power of x. Now we want to show that 1/2 lies on the line. So let's substitute in x equals 1/2, and we should get y is equal to 1/2 2. So when x is a half, y is 1/4 to the half, which is the square root of a quarter, which is 1/2. That shows it. Cool. Okay, 28, the grand finale. Now, just to put you in the picture, I gave this question to my AS levelers just out of interest, and they couldn't really do it. So, it's pretty hard, especially part B. Part A is alright, part B, what a monster. Right, Izzy runs an 80-meter race in 14 seconds. During the first 6 seconds, her speed increases at a constant rate. During the last 8 seconds, her speed increases at a different constant rate. Her speed at 14 seconds is 2 meters per second more than her speed at 6 seconds. Here is a sketch of her speed time graph. Cool. Part A, 2 marks, wants us to work out her acceleration during the last 8 seconds, stating the units of our answer. Okay, so we know her speed at 14 seconds was 2 meters per second more than her speed at 6 seconds. So, acceleration is change in speed over time. So here, that's 2 meters per second over 2, no it's not, over 8 seconds. So 2 over 8 is a quarter, and acceleration as mental units, it's meters per second, meters per second squared. Cool. Here we go then, part B, A-level mechanics, pretty much. So, when Izzy finishes the 80-meter race, her speed is v meters per second. Work out the value of v. Right, first thing, distance is area under the graph on a speed or velocity time graph. So we know the total area is 80. Now, we know that speed at this point is v meters per second. Now what we're going to do is draw a line down here as well to 14 seconds. Now remember here we were told her speed at 14 seconds is 2 meters per second more than her speed at 6 seconds. So we're going to split the area into two shapes, a triangle and a trapezium. So we know that her speed here is 2 meters per second slower, so that's v minus 2. Now I'm going to call these two regions A1 and A2. So we know that A1 and A2 is equal to 80. So we now need to find these two areas in terms of V. So A1 is a triangle with a base of 6 and the height of V minus 2. So area of a triangle is base times height divided by 2, so that's 6 times v minus 2 all over 2, which is 6 over 2 cancels to 3, so we get 3v minus 6. Okay, then A2, bit more of a pain in the arse, trapezium. So trapeziums, you need to know it. Top is usually A, bottom B, height H, area is height times A plus B all over 2. So here, our top length is v minus 2, our bottom length is v, let's put these in, v minus 2, v, and our height is 8. So A2 is 8 times v minus 2 add v all over 2. Now that is 4 lots of 2v minus 2. So that's going to give us 8v minus 8. So that is A2. So we know that 3v minus 6 add 8v minus, forgotten already, minus 8 is equal to 80. So 11v minus 14 is equal to 80. Add 14, 11v is equal to 94. And then finally, they don't even give us a nice answer. V is 94 over 11, which is 2 seconds. .5 meters per second. Cool. Right guys, paper done. I honestly think that's probably the worst GCSE paper I've done so far. So I really hope you found this useful. Don't forget, give us a thumbs up, get subscribed, take it easy, take care.